Lesson is about the Gini index and the Lorenz curve. And to understand them, I took some numbers from the American Society. I believe these numbers are from 2016. The left column here represents the bottom percentage of wage earners, and the right column represents the percentage of overall income that they generate. So, for example, this line here represents the fact that the bottom 20% of wage earners earn about 5% of the nation's income. This line represents the bottom 40% earning about 15% of the nation's income. Skip down to this one here represents that the bottom 80%, which is most of us, earn 53% of the nation's income. This line, of course, represents the fact that the bottom 100%, which is everybody, represent or earn 100% of the income, which is all the money. And of course, this line represents the fact that the bottom 0%, which is nobody, earn nothing. And every society has its different distribution of these numbers, but what I've done for the American economy is I've plotted them here. You can see the 6 individual dots here, and you can see that there's a red curve that approximates those, doesn't hit the points exactly, but approximates them. And I've calculated that to be this equation here that you see at the bottom of your screen. That equation is called the Lorenz curve, and every society has one. Every economy or society or country has one. And there is a slight difference between the 6 points plotted and the curve values. So if you look at the top of the screen, you'll see that I've compared the in real life numbers to the model. The model numbers just refer to the value of the equation at those points. And if you look at the 2 columns of numbers on the right, you'll see that they're pretty close. There's no way to get a perfect curve. Well, there is, but it overcomplicates things so greatly. So for simplicity purposes, I found a Lorenz curve that isn't exactly through the American data points, but it's close enough for our purposes. You'll notice on this graph, we also see the line y equals x, the straight line from the point 0, 0 to the point 1, 1. In some sense, if this represents a society where, for example, the bottom 20% of earners would earn 20% of the money, the bottom 40% would earn 40% of the money, and the bottom 60 would earn 60%, and so on. And the only way for this to happen, of course, is for every single person to have exactly the same salary in a society or the same wages. So when it comes to the notion of inequality, and by the way, when economists use the word inequality, they're not placing a value judgment on it. There's no issues of good or bad here. But the inequality in a society is, economically anyways, is measured in some sense by this yellow shaded area. In other words, how far is the economy's Lorenz curve away from the line y equals x? And sometimes that's called the ideal line, but I don't want to again place value judgment. If there were a society where every person made $1 a day, then they would have that y equals x as their Lorenz curve, and that doesn't sound like a very ideal place to me. But again, we're not putting judgment on anything here, just doing numerical measurements. So economists have over the years somewhat agreed that if we could find this area between an economy's Lorenz curve and the curve y equals x, that in some sense that would be a measure of the country's inequality economically. Let's compare that to a country whose Lorenz curve looked like this, where in a way you could think of this as the most inequitable society financially, where one person had income and literally everybody else's income was 0. You could think of this as, in some weird way, someone having all the money in a society, and that's about as inequitable as it could get. And there would be a certain area associated with that as well. And so economists have decided that how area A compares to area B could be a measure of a country's economic inequality. So it was decided that the Gini index, or this measure of inequality, would be the area of A divided by the area of B. But this extreme society B, in which one person has everything and everyone else has nothing, the area of that curve is a half, or under that, between that curve and the line y equals x. And so a shorter way to think of the Gini index is just to compute area A, the one in yellow, and double it, because after all, dividing by a half is the same as multiplying by 2. And so, for the purposes of this course, when you're asked to find the Gini index of a particular economy or society, you'll simply find the area between y equals x and the Lorenz curve. You'll find A and double it. Let's do that for this particular data from America from 2016. You'll recall from Calc 1 that you can find the area between curves by integrating. You may even remember that we integrate from the left x value to the right x value of the top curve minus the bottom curve. This is not an official formula, but this is essentially what we learned in Calc 1. And in this case, the top curve is x, and the bottom curve is the Lorenz curve that I found, or at least the closest one I could find to get near the American data. Now let's go through the mechanics of calculating this integral. First, I distributed the negative sign, and then I integrated term by term, because if you're integrating a 3-term function, you can integrate one at a time. So I found the antiderivative of each term. By the way, it's worth pausing to note here that for the middle term, I used a u substitution, u equals 2.6x, to get that. As you'll recall from previous semester, we evaluate this integral by plugging the top number, or 1, in and subtracting the result we get by plugging in the bottom number, or 0. Here is all the mess of me plugging in 1 and 0 and subtracting. You'll notice the value that the constant c's cancel out, which isn't surprising. Many people just don't even put the c there at all. And all the other stuff got done on a calculator, and this whole mess crunched down into 0.196 approximately. And so what I found is the area of A is about 0.196. Now the Gini index, which is a 0 to 1 scale of inequality, 0 being perfect equality, again, not necessarily a good thing, but maybe, 0 being perfect equality and 1 being total inequality. All we have to do to find Gini index is multiply that area by 2. And this particular time in American history, our Gini index was about 0.392, or roughly about 0.4. It's worth comparison, just if you're interested in society and politics and countries, that many of the European countries have a Gini index of about 0.3 compared to about 0.4, which is what we had in 2016, and I believe still have today. And that completes the lesson.